Hallo Freunde, es ist 10 Uhr in Redmond, Washington am Dienstag und willkommen zurück zu .NET API Review. Yeah, that was probably mostly right. We have a huge amount of stuff in the hopper right now, though it looks like the cutoff of things marked as 10 is two-thirds of the way down my screen, so yay, we're future planning, I guess. I don't see Aaron. Is anyone here capable of talking about the Java marshalling API? All right,
I doubt it.
we'll leave that in future first. All right. So I guess that means first up is a revisit on .NET Runtime 113562 claims identity to perform case-sensitive comparison. When we previously talked about it, we approved this constructor and where's the but that didn't cover two other patterns of construction that were not representable with this. One where you build a claims identity from a binary reader, and one where you use it as a copy constructor. So the proposal up top was right. So in addition to this constructor that we previously approved, it wants to add the new string comparison option with the binary reader and the claims identity inputs. Since these two can't meaningfully be combined with any of the others, they're separate. Okay.
There are already constructors that take a binary reader. Like there's already a well-known format that this reads.
Yeah.
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 Definitely wouldn't add a new one at this point. But yes.
I'm pulling it up.
I was going to ask if we'd even. I mean, I suppose, yeah, we probably do care for. I could imagine people pasting cookies and stuff off that.
Yeah, so the copy constructor from claims identity to claims identity and the binary reader constructor both exist and are not interleaved in the rest of these things. I mean, we're also not resurrecting the serialization, or we're not resurrecting the serialization info one, but the it has
where does where does the string comparison come into play? And they're currently doing the equivalent of ordinal.
So if you've built a claims identity, you can have it write to a binary writer, which just saves all the claims that it had, and then resurrecting a claims identity via the binary reader over that same payload brings back the claim data. But the only place that the comparison matters is when you call find, of when you're looking now for the type, and that's the where it is ordinal or is ignore case, and they want the other one. So, yeah, we're just squaring the circle.
Why aren't sorry? If this only matters for find, why isn't this just an overload of find?
It's not just find. I mean, there's like find first, and I mean, yeah. I think there are a few other things, like remove
the
claim, stuff like that.
Yeah,
has claim.
When we previously, the previous proposal for the functionality had suggested that, but since find is virtual, and part of the reason people were doing the overriding was to change the case sensitivity of find. It seemed like adding a new overload was just going to complicate things because it would presumably defer to the existing find, which it couldn't meaningfully do.
But doesn't the opposite also hold true? If someone constructs one of these with a string comparison, ordinal ignore case, and a custom overload of find all isn't paying any attention to it because that was never a thing?
Right, yeah, so that's why we didn't overload find. We changed the constructor.
No, I'm saying,
so you've directly constructed it, so you called new claims identity and passed the thing.
But if I'm deriving from claims identity and I'm overriding find today,
yeah,
and string comparison ordinal ignore case was never a thing, so I'm doing my own find.
Yep.
And now someone constructs this with ordinal ignore case, I'm not paying any attention to the fact that they changed with the desired comparison mechanism.
They couldn't construct your type.
Constructing your type. Yeah, exactly.
You would have had to have added the constructor that accepted it.
I see.
We didn't expose it as a property for that reason. It's an input only So this is basically just for if somebody wants to say base.
Like Identity already does this, or like rather like Microsoft Identity Web, which is like Entra's toolkit, which we kind of use in ASP.NET Core.
Is it going to be a problem that this doesn't round trip via serialization, via write to and read, or construct or whatever?
The write to doesn't have anywhere that it would be capable of representing the string the case sensitivity. That was when Kevin was implementing this. That's one of the things he ran into, which is there was a piece of data that he couldn't write down, which means he couldn't read it back, which means that the object wouldn't faithfully round trip, and that's why I needed the new constructor parameter.
Well, you need a new constructor, but it also is that a pit of failure?
Probably on the type, but it is what it is.
Yeah, I'm not saying that it's impossible to get wrong. Like you could have one piece of code serializing it that was, using case insensitive comparison and not somewhere else. But I will say like the state of the art is like people are already deriving from this and doing like case insensitive comparisons, and you can already serialize those things, and you can already like this
right, you can serialize them, but if someone has put the comparison logic just in a method, then there's nothing else to impact serialization, so that's fine.
Right. The only thing in the reader writer format is just basically the list of key value. So, yes, sending the binary reader to a derived type that does different casing is already a thing.
Yeah. I don't think it's going to be a pit of failure. Like, I'm not saying it's impossible to misuse, but I think it's okay.
And then the claims identity other copy constructor scenarios, because not all of these inputs are exposed back as properties, but the copy constructor does preserve them from one value to the other. So it's a sideways
broadly. Oh, sorry. Yeah, it's just like a way to broadly opt into case sensitivity, and it'd be nice if it round tripped automatically too, but like it doesn't. It's okay though. Like where you do construct these things, if you care, you can now choose to have case sensitivity. You don't have to update all the codes application level code that's already calling like has claim.
Okay.
Okay. Looking at the list of faces, still don't see Aaron or Jeremy. If somebody wouldn't mind pinging them, that would be great. Alright, SSL authentication options allow RSA PSS pad and allow RSA PKCS1 pad 114740. Radek.
Hi everyone. So this issue is specifically to enable one of our partners to expose some additional configuration knobs on the TLS handshake. And to give a bit of context, as part of the handshake, there is the signature algorithm, which is basically a tuple of I don't remember the technical name, but basically a signature algorithm and a hash. And the scenario which we are trying to enable is to give users ability to control which of these algorithms can be used during the TLS handshake. Basically, we want people to blacklist some of these algorithms. And the reason is a little bit why we want to do that is a little bit technically complicated. Not sure if it's useful to go into it here, but it's for those who are interested. It's in the links issue in ASP.NET Core. Basically, the API is just a simple flags which will say, hey, enable this group of algorithm or not, and we will want to default them to true, which is the current state, because we don't explicitly configure these algorithms at the moment anywhere. And for those who are interested and want to do something a little bit more advanced and know what they are doing, we also give them the ability to disable those specific algorithms. That's probably a good summary. Jeremy, you also know the area. Do you think I missed anything important from the context?
I don't remember why it was needed, because I thought that the cert was mostly going to cover it, but I do remember that there was a customer who got it, or whose state was backwards of what they wanted. So
the problem was that some of the TMP chips couldn't handle some of the algorithms, and it basically led to a situation where client couldn't connect to the server because it would try to compute the transcript hash of the handshake, and the TPM would fail on that, and that would prevent clients from connecting. So the solution to that, which some of the clients or like our users are using, that they disable the specific algorithm at the server side, so client will not be able to pick it up, so it will choose something which will work. So that's in short what the bug was about.
fair enough.
Radek, remind me, don't we have some API already that allows you fine-grained control over which algorithms are selectable?
Yeah, so we have TLS Cipher Suite policy is the name of the class, which is controlling different part of the handshake of the TLS, and that one we support only on Linux for implementation reasons. The stuff that is toggled by the proposed properties is also part of TLS, but is not covered by this policy. It's something different, and it does not belong into a concept of Cipher Suite.
And they're totally orthogonal. There's no overlap between them.
As far as I know, yes, they are orthogonal.
For older TLS versions, they're related in that these new options only matter these options only matter if the certificate is RSA, and the older Cipher suites cared about what the certificate associated was, but TLS 1.3 and newer say the certificate is what it is, and the Cipher suite's only going to talk about what we do after the certificate. So they're slightly related, but in a forward-looking way, they're not.
Thank you. There's a question from Levi, I assume.
Yeah, this is kind of in the same vein of what Steve was just asking. Are you concerned about the future-proofness of this API? Because I'm looking at, again, some of the other APIs. I don't necessarily see a block algorithm A, block algorithm B set of options as much as I see there's a callback model, for instance, where the callback model is querying dynamically. Here's a particular, I don't know, OID that is trying to be negotiated. Do you want to allow this? And then you would say no. That way you have the ability to, without making any API changes at all, start answering that question for newer algorithms that we haven't considered here. Like, is that something that's on your mind?
That is not something that could be implemented with the underlying crypto libraries, I believe. So, for example, on Windows, since everything happens outside of the process with the S channel, we can give it some options. Hey, like, don't use these ciphers, but we don't get a place where we can plug a callback and pick from a set of possibilities. So I don't see a way how we would implement, for example, a callback. And as for other possible algorithms for which we might want to add toggles in the future, from what I understood from Jeremy's comments on the issue, only the RSA related algorithms have some sort of like parameters or like different versions, and all the other ones which have came after that are like don't have like different versions. And maybe another thing that should be mentioned, there is already like a first pass filter. So if for example the server is using Edwards curve certificate, it will not be even like be possible to use those RSA padding whatever signature schemes. So those properties would only be relevant if RSA certificate is used, and with no other certificate type there is currently similar issue.
I couldn't help but notice the word currently multiple times in your response. I am nervous that we're making something that's very 2025 centric in terms of an API design surface. But like you said, if this is also a limitation of the underlying OS where we can't make anything better, then I guess, all of my concerns are kind of moot at that point.
Right. So I have on screen right now the list of, as of 2018, all of the signature values. The hash associated with the signature you can identify from the TLS cipher suite that was chosen. So you can already get that from metadata. And then you can get the family of RSA, ECDSA, etc. from the certificate. For ECDSA, you can get the curve from the certificate. But then the only thing that you can't tell from the combination of the certificate and the cipher suite was RSA PKCS1 or RSA PSS used in the signature. And since everyone involved in crypto algorithms seems to believe that the pigeonholing those two things together instead of calling it an outright new algorithm was a mistake, I don't see it actually happening again in the future.
Okay.
Is my take.
Because going forward, we actually have like independent OIDs and all that good stuff.
Right. So like for SLH DSA, which has 18 different OIDs, you just look at the certificate and you'll reject it based on the OID. But RSA, you get the RSA encryption OID for both RSA PKCS1 signatures and RSA PSS, as well as if you actually encrypted something, because the OID was named stupidly.
Okay, I retract my concern.
So, my only... so I guess the concerns and questions that I have are, it's proposed as calling it allow, and I know that we go back and forth on should things be called like allow or deny or enable or disable or whatever, because sometimes we have the notion of if you need to write the line of code, it should be because you're changing the behavior. So it should tell you, look at this if you want to disallow RSA, instead of, oh, it is allowed, now you need to turn it off. So there's what state do we want that to be on? And then what behavior are you planning on having if these are set to So if it's false, false, and you give an RSA certificate, that's going to need to fail. But are you going to fail if either of these is set to false and it's not an RSA cert, so they didn't matter at all? Or, yeah, so those are the flavors of the question.
Okay, so before I dive into that, for the allow prefix, I think we have precedent in the allow TLS resume or enable TLS resume, I believe. So I don't remember which one it was, but basically I would use the same prefix over there. As for your question, if you set both to false, and you try to use RSA certificate, it will fail anyway somewhere in the crypto layer. So in order to give better, more user-friendly message, it probably would be better to check for this somewhere, let's say inside authenticate as server async or at this layer to fail more quickly with something more useful. We don't have a preference. The failing faster probably is a better solution for the user.
And then you're just going to ignore them on a non-RSA certificate?
Yeah, if you decided to check earlier, then we don't necessarily know. Well, we would have to check the kind of certificates, which I'm not sure if it's is the amount of checking we want to do. Also, I think there is also the question, like if you disable those on the client and connect to a server which has RSA certificate, it will still. Actually, no.
I guess the other question is, what does it mean for the client? Is that just for mutual TLS? Of how the client's going to sign with their own cert?
We have decided to do it symmetrically already because on a crypto layer, it can be set for both client and server. And basically, I think under the API usage, there are 2 bullet points which summarize what happens when you set the property. So if you set it on authenticate as server, 2 things will happen. The server is the one who is picking the signature algorithm for the server authentication. So internally he will decide not to choose it. And if we decide to do mutual authentication, so we ask client for the certificate, in the certificate request message, there is a list of signature algorithms that server is willing to accept. So in this message, the server will not list the disabled algorithm. When we do it on the client side, the situation is reverse. So basically, client will not announce, "Hey, I am willing to use this. I'm not willing to use this signature algorithm." And on the other hand, if mutual authentication is desired, it will not pick if they are offered by the server. So both of them make sense on either side of the connection.
Right. So, I mean, I understand the. And sorry, I'm like massively jet lagged right now. So if you answered this and I didn't get it, that's fine. I apologize. The options make sense for I'm about to use a certificate and here's how I want to use a certificate. But are you also using them to judge the other side?
Yes.
So if the server has my TPM, I'm using a TPM, which is actually a bad idea for a server cert, but I'm using a TPM that doesn't do PSS correctly, so no, don't allow PSS padding. But then the client uses PSS padding, you're going to fail the connection by policy, even though what they were really trying to say is my TPM's dumb.
Yes,
Okay.
because the thing is, we don't have the granularity on Windows to allow it only on one side. Sorry, no, that's yeah. We are not able to control like separately what we send in, for example, client hello, and when we are picking which signature algorithm to use, in S channel, we can only say, hey, I don't want this algorithm to be used at all. So we don't have the granularity to decide, I don't want to use it locally, and I don't want to tell the other side to use it. Which probably makes sense, because if client decides to use it, I need to compute it locally to verify it locally. Maybe no, sorry, maybe. Yes, forget I said it. Basically, bottom line is we don't have the granularity on Windows, so we have to apply it on both sides.
Fair enough. Okay, and then the suffix pad, my gut says we either want to remove it or make it padding, because we already have RSA padding as a type somewhere, but maybe people don't care.
Yeah, for the name, I'm open to suggestion, because it's I don't know what kind of guidelines we have for these like crypto names. Basically, what I did was take the S-channel identifier and change the naming convention from screaming case to Pascal case, and added that allow prefix. So if you want to decide on some more descriptive name, I don't have objections.
Levi, do you have thoughts?
No, naming's always one of those weird things. What's proposed here, honestly, I don't have heartache with. It seems straightforward enough.
Probably padding, as Jeremy said, would make more sense, since we already have like the type something. What is it? X509 RSA padding. I think I mentioned it.
Yeah, I should have clarified adding the ding at the end, but yeah.
Yeah, I also prefer it with ding.
And I was also looking at the conversation about what does it mean if the certificate just isn't an RSA certificate, and I think that's still okay, because this is saying allow, not require. So like there's no obligation that you have to use it.
Yeah, and if it's being used as a filter on the opposite side, then I guess that also answers that question of, sure, you both picked ECDSA, so it didn't matter, but if one of you picked RSA, it would.
Yep.
All right. Anything else?
Not from me.
Sold.
Thank you.
Thank you. Alright, I think we still don't have anyone from Interop. Okay. Alright. Another system security revisit. Amend MLKIM, MLDSA, and SLHDSA import encrypted PKCS8 private key. This is runtime 115024. What we previously had were string goes with string and span goes with span, but one of our overloads, we took a string password with a span input, and that was not easily usable by PowerShell, and so we want to change that from span to byte. And Pranav, remind me, did we want to change it or did we want to add?
We wanted to change it.
Okay.
Get
Okay.
rid of them.
That's what the diff
Because
says.
the existing read-only span char one will just work for string, right? So we're not losing anything.
Yeah. That's true. If you do have a span, it will. If you're on framework, you'd have to dot as span. But
Yeah,
otherwise, it's fine.
Isn't there like weirdness with null handling though? Because this is a non-nullable password being passed in, right?
It should be a nullable password.
Okay.
So basically, the implementation.
So there should be a question mark there.
I think there's a question mark there, and when Kevin was writing up the proposal, he just, didn't care because it's question marks. I'm looking.
So basically, the implementation here is just going to defer to the one that takes read-only span char, read-only span byte, right?
It'll null check the array, but yeah.
Okay, yeah, but otherwise defer down. Okay.
Oh, and I guess like for importing, it's not as bad as exporting. Like if you import with a null password, you're just going to get an error. If you export with a null or empty password, you could end up undermining your security, which is a lot more severe.
Yeah, well, I think
So
it's null and empty are the same unless it was encrypted using the PKC or the PFX algorithm, in which case they're different. So
yeah, I guess what I was getting at is I know that there are cases where I've seen this in Windows a few times where people inadvertently passed in a null password and ended up having something not encrypted at all.
Yep. Actually, no. It says we throw for passwords, so I guess the PFX algorithm probably doesn't make sense here.
Yeah.
Yeah. So yes, this is null check both arguments and then call the span ones. So yes, doing a dot as span on framework will mean that you get to bypass the null check. Okay. That means you did it in your code. You chose to do it.
For import, that's okay.
Yeah.
Yeah, but for import, that's okay. Because it's either going to work or it's not. It's not like you're changing the result.
Right.
Okay. I have no further comments. Yeah, it's always fun to kind of wrap your mind around what are the consequences of somebody inadvertently turning a null into an empty here.
Yep. All right. Again, assuming no Aaron. All right. Runtime 114731 BigMul for nuint and nent.
Yeah, so the basic premise here is that we have already exposed a BigMul API for all of the other integer primitive types. We just didn't have it on inint and inuint. There are algorithms where this is useful, particularly for things like big integer, where you might end up having an implementation where you use int on 32 bits and inint on 64 bits. That way you can correctly optimize the carrying logic yourself. There's some community members that are interested in doing that for our own big integer implementation, or that are already doing it for their external ones, and so they've been asking for us to expose these additional APIs.
We seem to be rather inconsistent with the names of these parameters. AB and out low is true for most of them, but uint 128 are left, right, and out lower.
Yeah, so system.math used the AB convention for all of the primitive types where we were exposing the net new APIs. We went with left right because that was better. For the concrete types like int and uint, we just return the next bigger size. So rather than having an outlow at all, we have uint left, uint right, and it returns a ulong. Now for int 64 and int 128, or for int 64, we also do the same thing where we return an int 128, but for int 128, we named it left, right, and out lower.
Why doesn't this return an int 128?
Because it'd be twice as many bits on a 32-bit platform, and so it'd be extra expensive.
I see. So it would be hard to get the performance back from that.
Right. We could instead return a tuple, which we've done for some other of the very primitive APIs like divrem, where we return a inuint lower, inuint upper tuple. But we tend to shy away from that, and there's not a lot of benefit to doing it for this API in particular. So I could go either way.
I mean, if you already have an established pattern where you have an out, may as well just keep it for ease of people like copying and pasting code.
Mm-hmm.
Is this also not defined on a static interface somewhere?
No, it's not part of generic math because it's the kind of thing that doesn't make sense for all numeric types. You would end up having to decide, what does it mean for a big integer to return a lower and upper? Does it mean that the upper is always 0 and the lower contains all bits? Does it mean that lower and upper are evenly split? Does it mean that lower is the the maximum number of bits between left and right, and upper contains any overflow? There's a lot of questions you'd have to decide. And the kind of scenarios where you really want a BigMul is when you're working with the primitive integral types instead.
Okay. So if we had like an I fixed width integer or something, then maybe it would make sense on that. Maybe.
Yeah.
Okay.
But then I don't think we're ever going to add such a type because I think at that point you'd be better with like is built-in numeric or is primitive integer or something.
Makes sense.
Interestingly, I was having the same issue with the batched random from months ago of can we make that generic, and the problem was, well, we can only make it generic if we assume that we know how bits work, which really means we want MI a sane built-in integral type.
Yeah. Is that in Corelib or a different package?
If we go forward on it anymore, because I haven't looked at it in months, then it would be in system security cryptography. I mean, it would also possibly appear in system.random, which would be Corelib. But
okay, yeah, so not something we could use an internal interface on.
Right. I mean, we need it in the public API to constrain the T.
Oh, okay, yeah.
So, yeah, no sneaky tricks.
Yeah, it's definitely an area that I think we might want to do something around eventually, just because we hit it enough in our own cases too. It's kind of like ISIMD vector, where there is plenty of need for it, but exposing the right public API surface is hard, and we've got other higher priorities right now.
Fair.
All
Ship
right.
it.
So changed AB low to left, right, lower. And fixed where my find and replace changed BigMul into RightIgMul. So started with a B. Good job, Jeremy. All right. Are we just flying through these today?
Sorry if I missed it. I'll slow us down. Do we expose the same pattern for uint28? Did we say that? Like, I see the APIs in source.net, but they look internal, but I might be looking at the wrong thing.
Is it internal?
The int128 BigMul.
Okay,
It
does actually look to be internal. So then we don't strictly have a pattern, and if someone wanted to say low is not the right word, we could deviate. But
Can we make that public as part of this?
Yeah, like why this and not that?
yeah, we should probably. It's because I thought it was already public.
Got it. Okay. See, at least it wasn't completely wasteful slowing down this time.
Fair enough.
I mean, is there any objection to approving it at the same time just for completeness?
I think we should.
Yeah, no, I think we should too. We have it defined internally because we use it internally for multiple things. So I thought it was public because of how frequently we use it, and other people might need the same thing.
Okay.
I have maybe a stupid question. I would intuitively expect that the return value would contain the low bits and the out parameter the high bits. Is the current version some established pattern that's used in other languages, or?
Yeah, it's also actually used by hardware in a lot of cases. The reason why you typically have the return value be the upper bits is because it's more convenient. Many algorithms use this as a type of overflow check. And they basically end up saying if the upper bits are non-zero, do extra handling because that indicates the carry happened.
Mm-hmm. Thanks.
So it's kind of like the try-out pattern in that case, where you return the bool to indicate success, and then the core result is the out. And in the same way here, you have the core result being the lower, and then the extra information which indicates overflow or not that you may end up also using being the return value that's the upper.
Yeah, I actually just dropped in chat a link to our own sources where we do exactly the pattern Tanner just mentioned.
But we do have the precedent of math.bigmul on long and ulong. I'm actually.
So should we just call it low?
Well, because that was when I was looking, and not paying attention to the fact that some of them were internal. Is all the ones from system.math were AB and low, and then the int128 and uint128 called them left, right, and lower, which are better names. And if these were
low,
on math, I would say they should match on math, but they're not on math, so we should go with the good names.
Yeah. Lower ends up low is one of those words where it feels like people were trying to make it too short unnecessarily. It's like using LO and HI in a bunch of places when lower and upper are not only the same length, so they make the columns align nicely, but they more accurately describe that it's the lower and upper bits of the result.
And anyone who cares about terseness is not writing these out anyway, so it's fine.
And then, how does so I'm actually a little surprised, but it's matching, so I'm going with it, that we return a signed value for the low bits?
Yeah, that's a it's kind of an interesting it's interesting from two perspectives. One, if you wanted to end up extending that to the full type, then taking the signed type naturally extends up to an int 128 the way you would expect, or to a uint 128. So if it starts off with all signed bits, then it will sign extend all the bits up. So, -1 stays -1 as it becomes a new signed type when the bits are consistently typed. But it is a little bit of a weird nuance where sometimes when you're talking about bits, you want unsigned and sometimes you want signed. It's just matching signed ends up working better in generics with various code gen patterns and with the semantic behavior users expect when taking just part of the value and extending it up to a larger size.
Fair. It just means that for the signed one, your overflow check is actually did you get a confusing sign as your result, and the upper bits are 0, or nor, or whichever.
Yeah,
you need to check one extra bit.
Yeah, it's specifically, it's still one check. It's just instead of does not equal 0, it's does not equal the same bit, the most significant bit of lower replicated. So it should either be all bit set or 0, matching the value of the most significant bit of lower.
Right. And for signed negative return, yeah, so that's what you were saying, is it'll return all bit set in the upper register not being needed. Okay.
Yep.
All right. I don't know how the tool is going to handle it, so I'm going to say that, and then that, and we'll see where it puts the video marks. All right. I don't want to talk. All right, we'll talk about this one first because it was actually in the agenda. RSA PSS salt length 104080. So, speaking of RSA paddings, in RSA signature padding, we have a property that people think is an enum but isn't, returning one of these instances, and it's called PSS. And what we've always meant is a particular set of options where the salt length in PSS, which is an option, is the same as the length of the hash. It's the only value Windows supports. It's the 99 percentile case. It's enough that we've ignored this option for 10 years now, but some people have come with like, hey, I have this signature generated externally and I need to verify it, and you're over-representing an option, so they want us to be able to expose it. Since this is weird and is basically going to always fail for almost everybody, we don't want it to be too easy. So if you want to create one of these, we moved it to a static method. So you'll see RSA signature padding.pkcs1, RSA signature padding.pss, and then you can call RSA signature padding.createPSS and give an opinion on as to salt length. Since it's an input, we give it back as an output. We'll fix that A to an E, and the default will be -1, which is do the same thing. We have to pick -1 as the sentinel because unfortunately 0 is a valid number. And then we expose a second. I don't know the answer, but I want you to do a shape patterny thing because OpenSSL and I think this is actually what some of the TPMs are doing, which is part of why they don't work for PSS, is make the salt as big as you can, which depends on the size of your key. So 2 special values and a new property and a factory method so that you can. Oh, that actually needs a return type too. Well, we just totally messed
I was
this one
about to say it's returns int, right? Am I understanding that correct?
Returns an RSA signature padding.
RSA signature. Okay. Then what is the const? Sorry, what? So, what? Where do I pass in? Yeah, what is the PSS salt length is hash length thing?
So you could call create PSS with -1, or you can just use the existing RSA signature padding.pss, which will be the same thing. And then the reason that this is exposed is so you can look at the padding object and ask, is the salt length the same as the hash length? And that has to be a meta-syntactic thing because you don't know what the hash is at the time you're inspecting the signature padding option. So
and the return type is like a wrapper around the bytes, the RSA signature padding.
Yeah. So this signature padding is already it's a class wrapping an enum because we planned on if someone asks for this, we'll do it. Except when someone asked for it, we said we don't want to do it. But then they kept asking, so then we said okay. So yes, we have the mode, which is the enum, and basically no one ever interacts with RSA signature padding mode. They just talk about these two static instances. And so
all it captures is the mode?
All that it currently captures is the mode. So now it's going to be the mode plus an int. And yeah, so this is just an option. Because the algorithm has the option, our recommendation is that no one ever use this, but if you're forced to by external specs, then you have to. And it's
everyone
just
else
going
will use the static property. So
yeah.
There's like no other constructor. I got it. Okay.
Yep.
What about you instead of public constants using static instances like singletons for those two special values?
Well, this one is a singleton already. It'll be RSA signature padding.pss will have the salt length value. Salt length is hash length. So it will say -1. Then now we're just exposing what -1 means with a name. And salt length max is, again, like 3 people in the world, if that, will want it, and it's not worth creating something in somebody's face for.
So this is a concept that people are already exposed to when they dig into the weeds, what you're getting at, right?
Yeah. Yeah, so again, using this new API will fail on Windows and Mac and iOS and Android. But if you're on Linux, then it can work.
It's easy enough to platform check already, and we'll just throw platform not supported exceptions if you... Will this, or will we just... I mean, I guess we'll wait for create PSS, or wait for the verify data call, rather.
Right, so the calls... So creating the instance won't fail, but when you call sign data or verify data, or sign hash or verify hash, then it'll throw, presumably a platform not supported exception. Or, I guess, cryptographic exception, because if we pass these numbers down, if we pass this number down to the underlying system and it can't work with the number, then it's going to fail with a cryptographic exception. So, yeah, it'll be one of those two. We'll figure it out. But we don't want to fail it at the call to create PSS, because you could write your own managed RSA implementation and you could support it yourself. But the system provided ones will fail.
Seems reasonable. It seems like you foresaw this by not making this an enum to begin with, and like making it a singleton class. But anyway, seems reasonable.
Yep. Yeah, the Windows structure. When we invented this for .NET Framework, the Windows structure we have to pass the number because they foresaw supporting it. Oh no, actually they support this. They support the salt length customization. They don't support a different option, which is related. So sorry, I conflated them. So this will actually work on Windows. It's just it goes against kind of the recommendation. The answer is use the default, but if you have to use this, then use it.
Right, I imagine it might matter for interop with like other systems, obviously. So that's why you have to support like zero salts and stuff, even though you should always have one. Is that the general guidance? I don't know.
Yeah.
Are there protocols that require zero link salt?
I don't think so, but I double checked in the spec and 0 was a valid number. Because why not? Because I think this is just about making sure that two signatures over the same data are different. If the salt length was 0, it would be deterministic, which I think's fine, but the industry thinks is not. All right. Does anybody want to have opinions about our terribly long names here, or terribly names here?
Does it make sense to add the word Sentinel somewhere to the names? I don't think we do it anywhere else in the framework, but wanted to run it by you.
I agree that I don't think we use that anywhere else. Because we have like timespan.infinite is just the constant -1.
Okay. I suspect that it's really going to be a doc issue for the most part, just telling people like, here's when you would ever want to call this, or ever want to use a Sentinel value.
Mm-hmm.
Yeah. Okay.
Yeah, I mean it'll be in the basically the param docs for salt length of the length in bytes of the salt to use for PSS padding, or the special value PSS salt length is hash length, or the special value PSS salt length max. So, woohoo. So, all right. Now I wonder where the bad spelling came from. All right, still no interrupt. Okay. .NET runtime 115400 BitArray as bytes.
So I opened this, but I'm not in a great place to talk. So Tanner, you're available if you wouldn't mind.
Yeah, I definitely can. So the general premise here is much like with list of T or some of the other collection types, there are cases where you want to be able to get a span over the backing allocation that exists for the collection type. That way you can do your own optimizations or operations around it. In this case, there's a need for BitArray to be able to return the backing span, so it's proposed we just expose a read-only span returning as bytes API directly on the type. The nuance here is it will effectively lock the implementation into storing the underlying data structure in little endian format. So if we ever end up supporting a big endian platform in the future, or on mono for example, where big Indian support does exist, we'll just end up having a path that indexes the bits as if they were little Indian for the rest of the APIs, so that as bytes can continue being a zero cost method.
Does that mean that the implementation on a big Indian system is going to use 2 arrays? One that it uses for everything else, and then one that it uses for as bytes?
No, it just means that when actually indexing the bytes, it will do it in reverse order. So instead of indexing from bit 0, it will index from bit 31 if the backing array is uint, for example.
I see. So you're making the set and get calls.
Yeah.
Do the reversing.
Yeah. That way we can have one array. Everything still works cleanly. It's just we're indexing the bytes as 3210 instead of 0123.
Okay. So I'll give my usual. I don't like it when things return spans on things that can change. If you call, I believe calling set can grow the underlying array, which means that some calls to set will modify the data you see from as bytes, and some calls to set will not, because they will have caused it to generate a new array. Similarly, increasing the length will invalidate the span that is returned back. So I'm in favor of a span func of I want to work, like, give me all the bits right now and I'll do something with them, and I'm loosely supportive of it on collection marshal, but I don't like the current proposal.
Yeah, and I called that out on the
agree.
issue as well. That we probably want it on collection marshal instead.
Yeah, collection marshal I wouldn't have a problem with, but the fact that the span can be disconnected from the backing store makes me think it doesn't belong on the instance itself.
I'm not on my computer at the moment, but BitArray doesn't have an add, does it?
You can set the length.
Oh, I see.
You can have a bit array that you've done stuff to, and then you can say set bit 1024 to true, and it'll now grow to have 1024 bits.
I don't think that works. I think it's only if you set length. I think it's got a fixed count, and then it's only if you set the length. That way you still get bounds checking, and it doesn't grow arbitrarily.
Fair enough. I thought setting in the index was auto grow, but no, if index exceeds length, throw. All right.
Regardless, I think even just being able to set length is enough to move it to collection marshal. It seems fine there, though.
Yep. What would it even look like on collection marshal?
I think that there's a minor impact to that, which is that BitArray will need to move into forward.
Is it not?
It's in system collections, it looks like. We have extension properties, or we have static extension members now. It doesn't have to move. We could just define some. We could end up defining some, collections marshal extensions or something that adds the API to system collections or system runtime.
Right, but
drop services collection marshal.
But that type itself would then have to be public, so we'd have to put it somewhere and name it.
Kind of sounds better though than moving the whole type. If we don't want to do that though.
Well, I mean, the other option is to just put it on the instance itself, which I think we were all not a fan of, but is it the path of least resistance?
True.
It's
I
also,
think it's bad.
The tearing there's I'm not a huge fan of it being on the type as well, but at the same time, the disconnect of the span from the backing array isn't a safety issue. It's a it's not a memory safety issue. It's a general issue of you can hit the same thing if you end up doing var temp equals array and then array equals new a few lines further down, and you forget that they're now disconnected. So it's not really the end of the world.
Why did we do it for list of T? Why did we move that to collections marshal? Because I don't think that's a safety issue either.
No, it's not a safety issue
I think that
either.
it's just easy to make a mistake with lists.
Mhm.
It's easier to make a mistake with lists because you have super common APIs like add.
Yeah, so I will say the fact that set throws if you exceed the length, so set's not an auto growing, does reduce my hesitation. Because the concern that I would have is you've called as bytes, then you pass the bit array to some helper thing, or you do further logic on it, and you now are calling set bit, and that when you tested it locally, it all works. And then when you do it in reality, you ended up with a bit number that caused you to grow, and that now you ended up not seeing the call to set bit reflect. If that requires an extra call to change the length, then it's still possible, especially if you have that you've passed it out somewhere between your call to as bytes and the time that you're reading the bytes later. But it's less of a foot gun if set bit is not going to grow.
Yeah, the other two issues are if it ends up being a mutable span, like the other collections marshal types are, then you cannot, then it's no longer incrementing version when a mutation happens. And the other consideration, whether it's read-only span or mutable span, is that it will return bytes and up to it's returning a number of bytes, whereas length tracks a number of bits, and so it will technically give you access to n additional bits beyond the end. That could be up to 7 if we always slice to the lowest byte, or it could be up to size of backing data store. So 32 up to 31 additional bits today.
Is the idea that for the most part they would just be ignored? Because I could have, doesn't BitArray have like a 2-byte array API, which would then need to zero out the bits?
Right, that always zeros the bits, but at least I believe it always zeros the bits today. But if
it would never need to. But go on, yeah.
Yeah. If the user ends up, getting the bit array, modifying one of those extra bits, and then growing the length, then the backing state will implicitly contain that extra data. So there is some nuance there in how users can leak additional bit data past resizing and other considerations.
But that's something that I think we could address in the implementation, right? We would just need to be maybe a little bit more aggressive about where we zero things out during intermediate operations.
Yeah, potentially.
How much do we care about it? Sorry. So is it an absolute no-go on having the API return a mutable span of byte? Like, I get that it doesn't update the version property, but it's not like or version field, but it's not like it's some thread safe data structure to begin with. Like, you shouldn't do concurrent operations on this thing, you should synchronize them probably if you're mutating, like on your own.
I think it's just the same considerations as list at that point.
Yeah.
Like there's reasons why you would want a mutable span if you want to like write your own vectorized extension method or all kinds of other considerations. So
notably, we did expose a mutable span though for list, right, via collection marshal. Yeah.
Right. There's just nuance there on how it becomes more dangerous, and there's more reasons to hide it off on collections marshal at that point.
I mean, it seems kind of sad that we give a more limited API, given than list, if we think it's even safer than list, just because we don't want to go through the effort of putting it on collection marshal.
Well, I mean, I think there's a difference of once your collection marshal give me your backing data and I'm going to mess with it. I'm aware that I avoided the warranties. If it's an instance method, if we took what was on screen and made it not read-only span, then that doesn't feel as much I voided the warranty by reaching through a marshaller.
Right. So what I'm saying is if we got to pick one or another, one of the benefits of moving it to collection marshal is we're giving customers like the more capable API. The downside is maybe it's less discoverable, but do we want this to be discoverable? Like, or do we want it to be capable?
Well, there are already going to be caveats governing its usage. Like I'm going through the issue that's on the screen right now, and Tanner, I know that you were engaging with a bunch of folks in the discussion here, and it looks like a bunch of people want to immediately turn around and memory marshal cast it as like a span of int instead of a span of byte, which now means that we need to guarantee that we're giving you something that's 4 byte aligned at least, right?
Right. We're exposing it as a span of byte because we don't want people to have to consider endianness or that we might change the backing implementation in the future. Byte allows us to, use uint or byte or inuint or long or whatever type is most efficient, but still expose it in a consistent way where the indices of the bits increment linearly. So bit 0 is in byte 0, bit 8 is the first bit of byte 1, always.
Yeah, but what I'm getting at though is like based on the discussions on that issue, we have a reasonable expectation that people will immediately turn around and throw this span back through memory marshal to change the representation of it. And if we know that people are going to do that, are we also willing to say we absolutely 100% guarantee the span that we give you will always be aligned for int or new int or long or something like that?
I don't think we want to make that guarantee.
Then this should really be on collections marshal.
Could we make it a span of int instead of span of byte? Make life easier on ourselves?
No, because if we do that, we can never change the implementation to use long in the future.
Okay.
Yeah. Given that we know that people are going to turn around and reinterpret cast this, and we also want to say, by the way, that might not be valid. Like I really don't think we should put this on the instance itself.
Why would people reinterpret cast it?
Because of it in the actual discussion itself, people said that they want to project this as a span of int or a span of long, not just a span of byte. And you were actually engaging with some of those participants.
Right, but the wanting to and needing to are kind of two different things. People wanting to do something, and we can just tell them, no, you don't get that capability. Like if someone's writing an accelerated implementation, they're wanting to most likely use vectors, in which case they don't need to do any reinterpretation. Just using a vector 128 of byte is already sufficient. And if they're doing something like handling for uint, because they want to handle 4 bytes at a time, and they've got less than 16 total, then read uint32 unaligned will already do the right thing and be efficient.
But given the types of people who want access to these, are the people who want access to these APIs perf cowboys is what it comes down to.
Potentially, but then they're going to ignore the guarantees regardless, no matter where we
I
put
want
it.
access to this API, not because I'm a perf cowboy, but because I want to pass it into things on tensor primitives, distance APIs for doing 1-bit embedding manipulation. And I'm going to rely on tensor primitives to do the right thing.
And are you the expected majority use case for the API? Should we add it?
I mean, I'm the use case that I have in mind.
That's fair.
As the opener, it's what he wants.
And I know you said this at the beginning,
Yeah.
Tanner, but this copies on Big Indian, you said? Or
No. On the what exposing this API entails is that we will have to update the implementation to say on Big Indian, byte 0 exists starting bits 1 to 7 or 0 to 7 exist in byte 3 when we're reading the underlying uint. So we just
no
have
copying
to do
on either platform.
Yeah, no copying. We just have to update the indexing on Big Indian to account for the nuance.
And like before, this wasn't even exposed, so it's fine, right? Or was it? Like I guess if you passed in, like, was this observable before? We're not changing any behavior of any APIs that you call today, are we?
Right. No, everything we expose today ends up exposing it as functionally Little Indian, where if you were to observe it as a sequence of bytes, then you get bits 0 to n incrementing through the bytes as you go.
I see. And that might even end up optimizing those operations on Big Indian for those people who care. Like, let's see. Yeah. All right.
Not to try and spend too much time on this, but is what you said true? I'm looking at copy 2 and I don't see any Indian mischecks.
It should be.
Because if your
It's on line 795.
if your destination is an int array, then it copies as is with array.copy.
You don't have to do anything for
Oh,
ints, right?
I forgot that copy 2. So copy 2 will end up having to fix up copy 2 int, which is a thing that I forgot we supported here. Will have to also do a fix up.
Okay.
But
it's a copy 2 API, so cost is expected.
So on Big Indian, copy to int is now less efficient, but like we'll live.
But yes, I agree. There is a bit twist going on for the copying it to a byte array. So
it shouldn't actually be less efficient because you can do a reverse bytes or byte swap as part of the memory load on most platforms.
That makes sense. Big Indian would probably want to optimize for that with their instruction sets. Yeah. All right.
Okay. So it sounds like we're in favor of collection marshal, which is good, aside from the fact that collection marshal's in the wrong library. So does that mean we want to move this down into core lib, or does that mean we want to come up with a second collection marshal pattern?
I think we should just move it down. I mean, the reality is it doesn't actually affect, I mean, unless someone's doing something really, really, really special, it doesn't affect them because both these libraries are in net4f.
Okay. Well, if Jan does any yelling, it won't be at me, so.
I think the fact that we were all kind of surprised that it wasn't in core lib anyway indicates that this isn't really this isn't a crazy collection type, right? Like this seems like something that people would commonly use in applications. Maybe not commonly, but often enough.
It's like not that big either, I guess.
Yeah,
it's kind of big. only because of the SIMD stuff.
All right.
And maybe moving it down to corelib would actually allow us to make some interesting perf improvements inside of it too.
So I assume people want it to be a writable span once it goes to collection marshal?
Yeah. I could easily imagine wanting to blow away existing contents.
Yep. And then I assume the sane interpretation is once you've grabbed the backing memory of this, we don't care what you do to the don't care bits. I guess copy to might still need to be sane and say that it guarantees that they're zeroed, but the second call to as bytes, they're gonna be what you set them to because it wouldn't know when to invalidate them. So.
Right.
And are we keeping it read only?
I would say make it mutable.
Yeah. I mean, it's consistent with list.
Yeah.
Yeah, especially if there's no copying going on. If we're doing it the way we are, might as well.
Well, it would also allow you to use BitArray as kind of a variable length vector in order to do operations inside of them without having to have lots of allocations. Assuming you made the span writable.
Does anybody know why collections marshal as span accepts a null list?
Cool.
Since it accepts a null list, I let it take a null BitArray, but I'm very happy to remove that question mark.
I'm fine with the local consistency.
All right. List uses as span, but it's because it has span of t. Because this one we're saying we're projecting it always down to bytes. As bytes seems like the better name, which I think is what was proposed as the instance. So, move the method to collections marshal. Change it to writable, and because it's on collections marshal, that means the type gets to move to corelib. Happy?
Thank you.
All right. Java Marshalling API 115506.
Yay. Thanks for doing that. Okay, so the gist here is over the last few releases, we have slowly brought in other types of interop. I think the original one was Objective-C. We've done a little bit with Swift, and now we are on to Java. A lot of this stuff is constructing APIs that have already existed for mono supported scenarios, and this one is no different. The difference that we are making here is these are all managed APIs. We are not producing explicit native APIs. We project as much as we can through the native surface area, and if users need to access it, we describe that in unmanaged callbacks that you'll see in this API, or if they need to call it directly for whatever reason, they can project it using unmanaged callers only and passing another native function pointer from managed to native, or any number of tools. Native AOT has something. DNNE, which is a library that I wrote, projects native managed functions into native. So that's kind of the ethos that's behind this. What this particular API is trying to solve is a complex interaction between the .NET GC and the Java GC. I am absolutely thrilled to go through this complex dance that is going to exist here if we really want to get into it. But I prefer not to. But we can actually dig into it if we would like to. But this API was modeled after the Objective-C interop, which in and of itself is a very similar GC bridge. The slight difference is Objective-C is purely just ref counted. So there's an automatic ref counting system that is emitted when Objective-C is compiled, but in the end it is still ref counted. So it is deterministic. There's no shenanigans going on there. Java is not like that. This is a complex dance between the .NET GC and the Java GC, or the JVM GC, I guess, to be more precise. I don't really know where to begin other than if we scroll down, there is a very, I think, rudimentary API usage section. And I didn't, there's a lot of ellipses in there because I didn't really want to express exactly what's going on. But the gist here is in the application, early in application startup, the caller needs to, I guess the interop runtime, I'm using quotes runtime here. So Android for .NET or .NET for Android, one or the other. I can't remember which direction it is. Basically owns the interop. So it is a higher level library that creates all the abstractions that you would imagine. So the equivalent is we have RCW, which is the COM mechanism. There is I guess it is an RCW in our case. I think they call it a Java object wrapper. And there's the equivalent CCW, which is a Java wrapper that calls into .NET. And all of that stuff is provided by this higher level library. This is just the minimum of what is needed inside of the runtime for the GC interaction. When the application starts up and the Java runtime, the .NET Java runtime spins up, it needs to register for this cross-reference callback. This callback will be triggered by the GC at a specific time. Typically, that is a Gen 2 GC or a blocking GC. And that callback requests for this, what we are terming the GC bridge or second stage of the GC bridge, to do a bunch of work. One of those operations are to spin off another thread, do some work, and call back into the runtime and indicate that it is done doing that work. So that's what the initialize is. That's the beginning. That happens once in the application. And then the finish cross-reference processing is when your callback is done that you supplied, and it's not just the callback, it is all of the work that it may spawn off onto other threads. When all of that work for cross-references is complete, you call the second stage, or the Android runtime or the Java runtime for .NET will call finish cross-reference processing, and that is the sync. So there are two specific syncs for the .NET side and the JVM side, and one of them is the registered mark cross-references, and then when that one is finished, that is the other sync, which is finish cross-reference processing. And that is the dance between the two. The other part of this is in COM and in Objective-C and even in Swift, we have these ref-counted mechanisms. In COM, it is a ref-counted GC handle, which we don't expose. It's an implementation detail that isn't exposed. In this particular case, we do expose it because we are trying to not know a whole heck of a lot about Java other than names. But how that's orchestrated and composed is it's upstack problem. And the create cross-reference handle is give us an object, a .NET object, and a pointer. This context, it doesn't matter. We don't care. It is literally just a pointer-sized piece of memory. And we will give you back a GC handle. And that is a very specific type of GC handle. And it gets stored, and that is how the GC knows. That is how the GC reduces the set of objects to look through when it is trying to create these cross-references. And the cross-references are .NET objects pointing at Java objects. That GC handle represents the interesting objects to walk the graph of. And if we are associating a pointer size of memory with a GC handle, which already exists as an implementation, is a type of mechanism within the runtime, we need a very specific API to get at that for this instance. This is the first time we would be exposing the concept of a GC handle having an associated pointer and exposing it in a public API. Happy to answer any questions. Well, I guess the one other thing that should be noted, and this is something we should talk about, I guess, a little bit later, but this is currently from the business need and from the runtime perspective, this is really only neat on Android. But there is nothing technically blocking this from being used anywhere on any platform. It's just that what we don't really want is, because of the cost of this interaction with the JVM, this is not really something that we would like or we would recommend for ubiquitous Java interop, because there is an inherent cost and people are going to hit brick walls if they implement this in like server scenarios. Any questions? This is a horrible
is there a way we
interop
could
API.
Is there a way we could be doing it better that would enable those things we wouldn't recommend to be fine, and we're just not investing in it, or there's no good way to do it in a way that would be lower cost? Or basically, how did we end up with a situation where we have an API where we'd say it's only good for this one sliver and please don't use it for anything else?
It's not that, I guess I would say that it's not that it's not good for anything else. It's because of the inherent cost of the GC interaction model, there's so much lost performance. Just trying to reconcile the two GCs, there's just so much inherent overhead. And this is not really, go ahead.
Oh yeah, so to reframe that, because I think I was following you, is like you wouldn't use like, and I don't even know what it's called, like the Java version of SystemNet Socket or something that like exists in C#, or if there's an existing .NET library, it would be silly, right, to pay the interop costs. But like, if there were some sort of like high-level library, I guess that's the kind of point. I guess if it's a high-level library, you might be interacting on it via like marshalling over like REST APIs or stuff of that nature.
Yeah, I think you're calling out like the REST API, like that is going to be inherently faster. And the reason it is because you don't have to synchronize two GCs. It's just a bunch of strings.
Right.
Deserialize it, serialize it. So yeah, it's overhead for sure. Nobody's going to argue that deserializing a large object isn't cost, but relative to let's try to synchronize these two GCs because you want to have a very complex object graph because you've architected something interesting, which may be interesting, but you are just you're losing so much performance that it's just there are better ways to do it. Inproc is I would not recommend Inproc. I would collection of microservices or a collection of processes that are communicating through sockets or some sort of API, networking API is probably far more efficient and easier to debug.
I think I misunderstood than what you were saying. So basically you're saying that for the goal where we need to do something in proc, synchronizing the two GCs, this is as good as it can be. We need that for Android. For other situations, you have other valid approaches that are likely to be more efficient and that don't require a dedicated API like this.
Correct. That's probably a better way of putting it. This is purely this is the classic UWP WinRT scenario where you have a very complex interop UI stack, and so that's why it's needed in the Android scenario. Needed is a strong word, but we're trying to integrate naturally with an existing application model in another language, and it's all UI based. So there's really not a better way of doing it, or this is probably as good as it gets. But if you're not doing that, go ahead and do it, but there's probably more efficient, better ways of doing this.
And presumably this is already presuming a lot of that the CLR got hosted by a Java process, because the Java Marshal initialize, that's just going to be a Genie attach, meaning Genie already needs to be wired up, right?
Yep. Oh yes, this is following the Objective-C model. It's how does the current system work? Where are there affordances that we can make some performance benefits that kind of align with the core CLR ethos, and go down that route. But other than that, we're supporting an existing scenario.
Right.
And yes, this is 100%. This is the Java application is hosting the process. .NET is along for the ride in this case.
Right. And while you could maybe use this you have a .NET process and you fire up JVM hosting and you try launching Minecraft in proc and using this to start reaching into Minecraft internals, it's gonna suck.
Yeah, absolutely.
Yeah.
You could absolutely do this. You could invert it. It would just be complicated and not recommended.
I had to think of something written in Java. So, okay. So, I have two high-level questions. I guess maybe three. One, you're adding a use of GC handle when we just added GC handle of T and said we have no further uses of GC handle. Two, why are you taking int_pitter star instead of just being void star or void star star? And three, I don't understand user context. You said it just needs to be pointer size, so isn't that void star star?
Absolutely, 100%. There's nothing.
Because once this guy came in, it feels like you have to be unsafe. So stop using int_pitter and just use void star.
That's fine. That makes perfect sense.
Is my gut. So we don't need int_pitter get context. That's void star get context. This isn't int_pitter context. It's void star context. Unless I'm wrong.
No, you're absolutely right. You can do that. I think so. The original implementation that we were going with, there was literally only a need for a native int size thing, and I was like, well, what if you don't need to allocate memory? It's just a size of t size_t kind of thing. But void star works just fine. And I don't think we're going to be able to get away from allocating a little bit of memory for each object. I don't see that as possible at this point. Early aspiration that just kind of remained.
Okay.
The other thing that I guess I don't think anybody's going to push back too hard on this, but the other thing that we were, at least the interop people wanted to discuss, wanted to call out for not having this on Android is if this is only on Android, it is going to make testing substantially more difficult. Testing and just being able to run through this, because the GC interaction model would only then be, these APIs only exist in the Android stack, and it would be much easier to do development outside of Android, but it is technically only needed on an Android platform at present. And maybe that's just an implementation detail on a checked build. I don't know.
I missed it, but was there an answer to Jeremy's question about GC handle versus GC handle of T or the like?
Nope, I didn't make that. How would that work? I don't know what we would give for T.
Okay.
Would it not be whatever this object is? Or is that completely the wrong paradigm?
Well, okay, so that's an interesting point. What this does, so that kind of becomes an implementation detail. And the reason I say that is because at present, the current Android stack, every Android object inherits from a base class Java object. It's the equivalent of .NET's __ com object. It's the root of all Java objects. In this model, since we're just taking object, and because we are creating a GC handle, and the upstack developer creates their whatever hierarchy they want, and every object that is associated, every GC handle that has an associated object from this API is the interesting type. We're no longer really at the mercy of creating complex type hierarchies. That's not a requirement for this API anymore. It used to be. I don't think that the current Java Android interop layer is going to change that particular model. So we could probably go down the path and say everything has, make this fully typed. It's not an unreasonable approach, but it is definitely not required.
I didn't follow that with jet lag brain. Is that leave it GC handle or make it GC handle of Java object, or GC handle of T with T object where object extends Java object, or none of the above?
Well, we don't have that's upstack, so we don't have access to Java object. That's the issue. So it would have to be of T.
Okay.
It would have to inherit it would have to be a class. Like, it couldn't be a value type or anything like that. So we could constrain it a little bit.
Sure. I mean, you already have that with taking object. You can take structs via boxing, but
right.
Presumably saying it's of T and don't give me a struct is actually better.
That's not, and honestly, if they wanted to do that, they could just pass object through, couldn't they?
Mm-hmm.
Yeah, that there's nothing wrong with that.
So GC handle of T will give you back the object. So presumably it's giving you back this object.
It is a GC handle to that object, yes.
Okay. And you made a handle here. What happens when you free it? I assume you're supposed to at some point.
Yes, it is. Well, in this new model, when it gets freed is really at the mercy of the GC, but you can imagine that it is just a strong handle. The implementation is basically just a strong handle. If you pass it in the finish cross references, like that's technically how it's supposed to, that's how it's supposed to be done in this model. There's a synchronization that allows the GC to know this object and all associated weak references to that object. It's just giving it more information, but there's nothing that's stopping someone from just freeing that handle like any other GC handle. Does that make sense?
Okay, but the average expectation is finish cross-reference processing is going to free it for you.
Yes.
So you call create, and then later say you're done with it. It's collectible.
Yep.
Okay.
If you want the full model, if you want it to preemptively say free it, well, then it just magically gets freed and the Java side stays up. And then when the when the GC interaction comes together, it doesn't detect that there's no relationship between the two worlds. And so it's just a regular Java object or just a regular .NET object.
Okay. For
and that GC handle, just to be clear, is an implementation detail of the Android for .NET runtime. That's never exposed, to the best of my knowledge.
For the finish cross, so maybe this is why you actually don't want GC handle and not GC handle with T. So if we're returning GC handle of T from create cross-reference handle, what are you passing to finish cross-reference processing?
Oh, it's of T, if it was of T?
Because presumably you can handle heterogeneous types in unreachable objects.
Yeah, if we were to do the generic version, we would change that to be int pointer, which is just the GC handle, the underlying GC handle PTR. That's what it would have to be. So it would have to be opaque.
Okay, so would we rather use non-generic GC handle or?
Yeah, it's probably not. That's a good point. We would. Yeah, I mean, there would be no real value at that point.
Okay. And you take this as a writable span? Is that important? Just usually, like,
No.
is this writing unreachable handles, or is this?
It's consuming.
Yeah, so it seems like read only because it's
That could
input.
be read only. Yeah, yeah. It is just input. Yes, that is the end of the line for those data structures.
Okay.
So just to clarify, when you say the end of the line for those data structures, like once I pass a GC handle in as part of that span, I shouldn't touch or store that GC handle anymore, correct? Like it's going to be deallocated out from under me?
Yes.
Okay.
Okay. Oh, hey, look, it fits on my screen.
But just out of curiosity, like, are there any real failure modes of this? So the free and deallocate things that we just talked about, like, we would expect that never to fail effectively, right? Like, if that fails, that means that there's something really unhealthy within the application.
As in the finish cross-reference processing, or
right? Correct.
Is there any reason that should fail? No, that can't fail. I mean, if that fails, we're in a bad spot.
Yeah, the reason I ask is because if we have any type of API that is, here are a bunch of effectively native handles, like please work with them and then deallocate all of them when you're done, and then say that gets interrupted partway through, am I the caller somehow responsible for any type of sane cleanup, or am I just the process is going down, like play taps and call it a day?
Got it. So that's the caller is halfway through deleting GC handles, kind of thing.
The callee, yeah.
The callee is halfway through deleting one. Yeah, that's not a recoverable.
Okay.
And to be clear, it's the callee in this case, finish cross-reference processing, that's calling gchandle.free. Or
Yeah.
yeah.
Yeah, I was just looking at this from the perspective of, are we making an API that potentially allows leaks on failure? But if failure is fatal, then nope, there's no leak. Hooray.
Yeah, I mean, I can even give it more precise on that. That particular thing is going to be done by the GC. We're going to be passing that back off to the GC to handle its lifetimes.
Okay. I mean, it's probably a weird question because it's all interop, right? And interop is intentionally reaching into like the guts of everything, but it just seemed worth asking from a design perspective.
That's fair. Is there any strong opinions on the Android side of things, the supported OS platform? Does anybody have a... I figure that was the response.
Personally, I'm fine with, especially in V1, slapping it in there, and if we have a compelling reason to widen it to, if you're in a situation where you have a Genie establishment, then we can remove it then. But so lock it down until we need to do otherwise.
Okay. All the structs, the first two structs, those are existing names from the mono environment. That's where they came from. The mark cross references was composing them. Just so we didn't have a function pointer with 6 arguments or 5 arguments, 4 arguments, something.
Mm-hmm.
Jeremy, is mark too much of a verb for struct?
I was gonna, like, is it marked? Because yeah, I mean the mark seems a little weird.
But you said that comes from mono.
Yeah.
But that's because mark cross references is the function, right? And they had in parameters, and you structified it so that you can squish the delegate signature.
Yeah, and so what that's doing is that we're asking, the GC is asking the GC bridge to do the marking. Because we're asking the Java GC to do more work. That's what that's all about.
Yeah.
So we just call it like cross references? Like,
Yeah.
what does it mean to be marked?
Yeah, I was gonna say it feels like the mark is adding nothing, and we should just remove it.
Yeah.
Or because it takes a components and a component cross references.
Yeah.
Oh, you already have component cross reference.
It's actually not a cross reference, it's a component cross reference is the field. It's a lot of But what does mark mean in this case? I mean, it's the action, I guess, like you just explained it. But yeah.
Because what we're doing is we're asking the other GC to do its marking so that we know that they know that the object is dead. It's like we've done ours. This is what the .NET environment has done what it thinks. Now we're saying, JVM, do the same thing and tell us what you think.
So kind of like in a finalizer, like these things can be continually resurrected if they're cross-referenced from the other side. Is that true? Or...
Yeah, like if the JVM detects that this thing's alive, then we just ignore it. We're like, all right, we can't collect it right now because someone else is doing something with it. So it is doing its own mark phase. It's extending our mark phase to do. It's their turn to do their mark. So it's definitely a GC term for sure. That is currently what it is called, I believe, in the API. But again, it's one of those. It's a native API. It's hidden. Nobody sees it. It's a pure native API. There is no managed. This is the first time this would be projected into a managed environment.
Yeah, I mean, it feels like if this was 4 flat parameters and you're squishing them up, we can look to the event args type and be like, screw it, we'll just slap args on the end. And it's the cross-reference args. Or the mark cross-reference args if we want. Throwing args on it buys a lot of this type is ugly, don't look at me.
Okay, that makes sense.
So, Aaron, were you recommending that we remove the Android limitation for the supported OS platform?
I'm not sure if it's a recommendation. There are affordances that we can put inside of our system. The downside is if we limit it to Android, we don't have to compile it in on every build. And so that's kind of nice because there's a bunch of infrastructure that we will have to create if it exists. And it puts, it's more work that the GC is doing that it doesn't need to do.
I see.
But as far as like what the business need is just Android. And, thinking about it, we can do tricks and say, well, if it's a checked build, this exists so we can run and do our testing and do development on it. Developing this API, you don't need Android. This is 100% agnostic of Android. It has nothing to do with it. It's just that's where it's used. And developing on an Android inner loop, this sort of GC interaction is very complicated and just painful.
Right. If I were you, I would just, not do it in an Android emulator, like at least the initial development. So that makes sense.
I assume your real question is, are we all comfortable with you saying that all of these in a retail build that isn't an Android build just throw platform not supported exception? And I think we're all fine with that.
Cool.
Yeah, I guess so. Could always not later, I suppose.
So
business needs change.
So what do we want for the name of this struct? Mark cross-references, mark cross-reference args, potato salad. And then the only
references and components. I don't know what a component is. It has a context apparently. No, I'm fine with defining the above. I'm even fine with mark cross references.
Yeah, I mean it's sort of it's under interop services Java. It sort of doesn't matter. Just let's pretend to care.
No.
And how do we feel about these
args, Aaron?
Lens?
Yeah.
I mean, I have a slight preference for mark cross references, only because that's the name of the callback that's called. But I like the addition of args. I really didn't know what to do with mark. I was even mark cross references args. That works for me.
Honestly, that turns it into a noun. So I think Jeremy's happy because now mark cross references is just the adjective describing the args.
That's fine.
Yeah.
Oh, I see. I misunderstood what your pushback was. Yeah, that makes perfect sense to me.
Is that length field supposed to be basically a size t?
Yes.
So nuint.
Oh yeah. Do we ever shorten length to lane? Is that a thing? Does it matter?
Yeah. Are all these unsigned?
Count the length. Yeah, all of those fine. The index gives me pause, but all the counts make sense. The only reason I say pause, I don't know how indexes can be negative.
Okay.
It's just common enough that it's there, but that's the only, and I don't even have a scenario for that, to be clear. It's just whenever I see an index, to me, it's not negative. It's signed or unsigned. Lengths, I agree. It seems like we're a little inconsistent on that. For example, spans length is an int.
Well, when you're not doing interop, we say use int, but this is interop, so.
Okay.
What's the native side end up using?
Yeah, that's why I asked if it was size t.
Oh, I see.
Covers.
I actually don't. So I made a prototype. I don't know exactly what the plan is. To be full disclosure, the Android team that is now working on the GC, they're the team in Prague. They did specifically say like, "Why is this signed?" And I'm like, I don't know. So feel free to making them unsigned is reasonable. It sounds like they're going to use size of T, Tanner. So at least that was how it was implied to me.
In general, I think since this is interop and since there are potential platforms where signedness matters, we should just match the sign of native exactly. RISC-V in particular is an example of a platform where, and even ARM64 and Mac OS, where you can have a struct that has two fields that can decompose into two registers, and those are sign or zero extended to fill the register based on what the source type was. And so in some cases, if you end up declaring your struct to use signed and the underlying is unsigned, you can actually end up with an ABI mismatch and a break.
Seems reasonable.
Okay, and looks like size T does guarantee unsigned.
Yeah, it's SS. It's S size T that is signed.
Okay. Well, I knew it was one of those platform dependent things, and I was just wondering if we were assuming things that were not true there. But it seems like it holds. Okay, I left a note that says if the indexes should be unsigned, then pretend it says nuint in the approval. So the lens, I don't think we have any lens. So it feels like it should be either lengths or counts. This one was a count. I know that if this was Win32, it would just be C components, but we're not Win32.
Count works for me. I know.
Is it components count or component count?
It would be component count.
Well, the field is components, right?
Yeah.
Yeah, but typically you end up having components, which indicates this is the list of them, and then you have component count, which indicates how many components there are.
Okay.
Because components count might imply that it's an array of a components array, effectively.
That's fine by me, yeah. For something like this, my preference is, I shouldn't say preference. The weight of my carrying is a little bit lower because it's obvious from context what's meant. So, like Tanner said, if that's a pattern, we should just follow it.
I mean, rarely do we have the counts on the same level as. I mean, I guess it's just in interop we probably do. It's common to have a pointer and count on the same struct.
Mm-hmm.
And as with any interop, every rule is correct to someone.
Yeah, exactly.
Exactly. I mean, as much as C components goes against our naming guidelines, it's easy. Put a C in front of the other name. So, okay. I feel like we're probably happy.
And I guess the final thing is, we're putting this in the Java namespace, not JVM, not GC Bridge. We're putting it in Java because that is how it is. That's how we've marketed it, and it follows
What about
Objective-C, Swift. It's language centric, not runtime.
Yeah, I think it's fine.
Is this going to end up being used for Kotlin as well, or is Kotlin distinct enough that it would need its own stuff?
No, this would be used for Kotlin as well.
Okay, and Java being ubiquitous for the JVM is probably fine then.
That's where we went with it. Yes.
Yeah, I was just initially considering it from the perspective of like, if there's anything that is going to be very Java specific instead of and it won't work for Kotlin at all, then is that the right thing? Or maybe we can just figure that out when it comes to it and differentiate at that time.
Sure. I don't. There shouldn't be any. At this level, there shouldn't be any issues with Kotlin though.
Yeah.
Okay, and then just to make sure questions are asked, your field order is correct for what you want in mark cross-references args? C components, C cross-references, cross-references?
Man, this is a tough question. I have always personally, like Tanner said, in interop, everything's got an opinion. My preference has always been length and then data, but
I just I assume you're passing this into another thing, and that you're hoping for like the x86-64 struct flat call. Should all of these be marked explicit layout? Sorry, sequential layout, because they're
Sequential's default.
it is the default, so we
Yeah,
wouldn't have to. But
fair enough. I mean, it's
we
the
can mark
sort
it.
of default. The C#, the compiler cares if you mark it versus it's the implicit default, but
I mean,
if you
from
don't
that
care,
perspective,
if you don't care,
that
you don't care.
perspective, it absolutely should be sequential. I don't really care. Doesn't hurt us to put it on, but doesn't cost us much, I don't think.
Yeah, it's just part of the explicit metadata, or the special metadata, so it takes up binary space regardless.
In general, does that affect the API surface when we mark the layout of a type?
If it's marked
Not-
sequential, you can do the explicit initialization differently than if it's not explicitly marked sequential.
Okay.
I don't think that's the case. I think rather it's that you don't get the warnings about unused fields when it's marked sequential, because because as far as the language is concerned, any reference it finds from outside the binary is going to be sequential by default, because it exists in metadata regardless of whether you specify it. Like, there's no difference in metadata for observation.
I may be thinking of definite initialization if it's in the same assembly, because once it's across as assembly, it wouldn't know the implicit versus explicit, I guess.
But it does sound like the layout affects how it's actually consumed within like a C# method, in terms of what the compiler either enforces or warns about.
It does do that. Like the big example is what Tanner said. If you
Right.
put this on the stack, and you don't have sequential, it's like you're not assigning this something. But if you do have a sequential, it's like, yeah, whatever, I don't care.
Yeah,
For some odd reason. I don't know the rules.
definite assignment cares, but it may only be if it's within your same assembly, because I don't think the layout, the implicit sequential versus explicit sequential, carries across metadata. So it's only when the compiler is building its model of the struct. It pretends it's auto until it writes it down, and then it was like, yeah, it was actually sequential.
Well, the reason I'm asking is because I don't necessarily think it's relevant to this particular API being reviewed, but I'm looking at the breaking change guidelines that are checked into GitHub, and I don't see anything about layout there, and I'm just wondering if that's maybe a gap.
I mean, it feels like the kind of thing that we always assume they're sequential. The only reason I really, really cared on this one is marking down because it's being passed through a delegate. Usually we only use a struct for data holding, but this one's being used for marshalling, so talking about layout actually becomes important.
Yeah, so having double checked, I don't think this impacts definite assignment at all. I'm pretty sure the only thing it impacts is if the fields are not publicly accessible, it makes a difference on whether the field is never used warning appears. Definite assignment appears to be the same regardless.
Fair enough.
Which is what I was remembering.
Okay, I thought it was definitely.
I think what you're thinking of is that in our manually defined ref assemblies, we have to explicitly indicate whether there's an object, an int, or any field. Otherwise, definite assignment ends up not requiring it if the appearance is an empty struct.
Fair enough. What I remember is when writing some Win32 interop in a past life, I got a compiler error, and writing down the sequential that is actually what the compiler writes down made the error go away. So I thought it was DA, but I would believe it's unused field. So, all right, I think we're happy. Glad you made it in time, Aaron. I mean, we're 18 minutes over, so there's a interesting definition of in time, but theoretically it means we now have no blocking issues.
Hooray. All right. See y'all.
Boop.
This is a good run today.
Yeah, we got through a lot. There's now only 2 things left marked for 10.
Oh yeah, I saw it just updated. Cool.
Yeah, it's slightly laggy. Cool. So yeah, we of course have a whole lot of things we can talk about next session. I expect we'll have blocking things again next session because we always seem to. But thanks to everyone for joining us and putting up with a bunch of less exciting things than we often talk about. But your feedback was definitely welcome, and yeah. See you next week at our same .NET time, same .NET channel. Until then.